Write 6 to the power of minus 2 and 81 to the power of a half without using indices. Now, an index is another word for a power. So the index here is minus 2. If we are talking about more than one index, we use the word indices. So the plural of index is indices. We saw in previous videos that 6 to the power of minus 2 is 1 over 6 to the power of plus 2. And if we want to write this without using indices, we have to write it as 1 over 36. So there's no index in this. Well, you could say 1 is an index, but it's not shown. Now, what about 81 to the power of a half? We saw in previous videos that the denominator in this power is the root. It's the root of 81. Because it's a 2, it means we're getting the square root of 81. Actually, what about the number on top? Well, this refers to the power that we raise 81 to. We raise 81 to the power of 1, and then we get the square root. Or vice versa. We could actually get the square root of 81 and then raise it to the power of 1. But it doesn't matter, because if we raise anything to the power of 1, we don't change it. So we're really just interested in the root here. It's a 2, so we're getting the square root of 81. You could put a little 2 here, but to distinguish this root from, say, the cubed root. But normally the 2 is not there. This is understood to be the square root of 81, which we know is 9. Express 2 to the power of 24 in the form a times 10 to the power of n, where 1 is less than or equal to a less than 10, and n is an element of z, correct to 3 significant figures. Now, z stands for the set of integers. That is, positive and negative whole numbers, including 0. Let's look at 2 to the power of 24. Okay, what is this number here? Well, it's got 8 digits. 1 million has 7 digits. 10 million has 8 digits. This number is actually 16,777,216. So we want to write this number as some number a, which lies between 1 and 10, and it could actually equal 1, but it can't equal 10. A has to be less than 10, times 10 to the power of some integer. So let's see how we form the number a. We form the number a by putting the decimal point between 1 and 6. So now we get a number that is in this range here. 1 has to be less than or equal to it, which is true, and this number a has to be less than 10, which is true. So we get this number here, which is referred to as a, and we have to multiply it by 10 to the power of some integer in order to get this back. Well, what do we have to do? How many places must we move this decimal point so it goes from here out to here? Well, let's just count them. 1, 2, 3, 4, 5, 6, 7. So we have to multiply a by 10 to the power of 7. 10 to the power of 7 is actually 10 million. So we're multiplying this number a by 10 million. 10 million is a 1 with 7 zeros, so the power just gives us the number of zeros. So when we multiply a number by 10 to the power of 7, we just move the decimal point 7 places to the right. Now we want this answer here correct to 3 significant figures. What does that mean? Well, we just want 3 figures in for a. So basically we want to round a to 2 decimal places. That's how we get 3 figures for a. So we look at the third place, which is 7. We see that it's 5 or more. We add 1 to the second place, so we get 1.68. 1.68 by 10 to the power of 7 is actually 16,800,000. So we've rounded up to the second place up to 8. In other words, 16,777,216 is closer to 16,800,000 than it is to 16,700,000. Now, this way of denoting a number, this way of writing a number in the form a times 10 to the power of n, where 1 is less than or equal to a less than 10, is sometimes referred to as scientific notation. Show that a times the square root of a cubed divided by a to the power of 4 simplifies to the square root of a. As we saw earlier, we know that the square root of a means a to the power of a half. We saw that up here. 81 to the power of a half is the square root of 81. So vice versa, the square root of 81 is 81 to the power of a half. So the square root of a can be written as a to the power of a half. And I just forgot these brackets around a times root a. Now we can apply some of the laws that were proven in previous videos. One law states that when we multiply two terms that have the same base, then we add the powers. So here we're multiplying a by root a, or a times a to the power of a half. Now a by itself means a to the power of 1. So when we multiply a to the power of 1 by a to the power of a half, we get a to the power of 1 and a half. We just add the powers. We add 1 onto a half to get 1 and a half. And this thing is raised to the power of 3. I haven't taken care of the power outside yet. In a video in the algebra section, this law is proved. A to the power of m times a to the power of n is a to the power of m plus n. Just add the powers when the base part is the same. So the base is a. So that's exactly what we did here. Now, in that same video, in the algebra section, you will see a way to deal with something like this. If we have a raised to some power m, and this term in turn is raised to another power n is some value different from m in general, then the result of doing this is to get a to the power of m multiplied by n. So we just multiply these powers together. So this is proved in another video. So we get 3 times 1 and a half, which is 3 ones are 3, 3 halves are 1 and a half. It's basically 4 and a half. Now, we're dividing here. We're dividing two terms that have the same base. We covered that in an earlier video. We say a to the power of m divided by a to the power of n. Then we get a to the power of m minus n. So when we divide, we subtract the powers. We take the power on top and subtract the power underneath. So we get a to the power of 4 and a half minus 4. 4 and a half minus 4 is a half. What is a to the power of a half? It's the square root of a. Solve the equation 49 to the power of x equals 7 to the power of 2 plus x and verify your answer. In a previous video, which is in the algebra section, I explained how to solve equations involving powers. We basically look at the base numbers, which is 49 on the left hand side and 7 on the right hand side, and convert them to the same base. Now the easiest thing to do here is to convert 49 to base 7. 49 is actually 7 squared. So we have 7 squared, which is 49, raised to the power x. So I'll put it in brackets for now, because I have to put it to the power of x. That's 49 to the power of x. That's what this is. And on the right hand side, we have 7 to the power of 2 plus x. So we try to get the base numbers the same. That's what we have here. Now, we have brackets here, so we can use this rule up here. A to the power of m to the power of n is a to the power of m times n. So the left hand side becomes 7 to the power of 2 times x. We just multiply the powers. And on the right hand side we have 7 to the power of 2 plus x. Now we have a single term on each side. This is just one term here and just one term here. And the base numbers are the same. Both terms are base 7. So the only way that both of these terms can be equal to each other is if the powers are equal. If the powers or indices are equal. So we put 2x equal to 2 plus x and solve. 2x equals 2 plus x, bring x's to one side, 2x minus 1x is 1x, we get 1x equals 2. That's the solution. Now we want to verify this answer. So what I will do is write this out again and replace x with 2. So I'll write out the left hand side. The left hand side with x equals 2. The left hand side is 49 to the power of 2. So x is 2. We could work that out on a calculator. 49 to the power of 2, or 49 squared, is 2401. If we look at the right hand side, we have 7 to the power of 2 plus x. 7 to the power of 2 plus x, x is 2. This is 7 to the power of 4. 7 to the power of 4 is 2401. So the left hand side equals the right hand side.